Hello, welcome back. This is your Professor Sudha Kolathuparambal. In part 1, you already learned how to graph a hyperbola when the center is at 0, 0. In this section, you are going to learn how to graph a hyperbola when the center is not at 0, 0. Also, how to solve applied problems involving hyperbolas. This is the standard form of equation of hyperbola center at 0, 0. This is starting with x square with a positive x square minus like that. So this will be a parabola in this shape. That means the transverse axis is on the x-axis. If the equation is starting with y square positive y square minus x square form, then the transverse axis is on the y-axis, and this is the shape of the hyperbola. If the center is not at 0, 0, the form will be like this. Here, if h and k are 0, then you will get the standard form of the hyperbola with the center at 0, 0, right? If the center is at some point hk, then the standard form is x minus h whole square over a square minus y minus k whole square divided by b square equal 1. Since this is starting with x square, the shape will be same as the standard form when center equals 0, 0. Only thing it is shifted wherever the center is. So it will be shifted hk. So it will be shifted h unit right, k units up. So it depends on if h and k, if it is negative or positive, it will be shifted left and up, or left and down, like that, based on where the center is. So depending on that, you can decide whether you need to add or subtract in order to find the focus. This is the equation of the asymptote when center is at 0, 0. Here the center is at hk, that means x coordinate, this is the y coordinate. So you can actually subtract h from the x coordinate, y minus k. So this is the new equation for the asymptote. If you add k on both sides, that is the same equation given here, plus or minus b over a x minus h plus k. Same thing, if the transverse axis is parallel to the y-axis, the equation will be starting at with y, but the center is at hk, right? Here h correspond to the x coordinate and k correspond to the y coordinate. So the equation will be y minus k, not y minus h, because we cannot write y minus h because h correspond to the x coordinate of the center. So the center is at hk, so instead of 0, 0, center is shifted to hk. Since the equation is starting with y square, so the transverse axis is parallel to the y-axis. And based on how the shift is, like a center could be here, or second quadrant, or third quadrant, or fourth quadrant, like that. Based on that, how the shift is, you can decide whether you should add or subtract that many units to the x or y coordinate to decide the shift of the foci. Similarly, the equation of the asymptote when center at 0, 0 and transverse axis is on the x-axis is given here. You learned that in part A. And if the center is at hk, subtract the x coordinate of the center from x and y coordinate of the center from y. Then you can add k on both sides. It will be plus or minus a over b x minus h plus k. That is the equation of the asymptote when center is at hk and transverse axis is parallel to the y-axis. Let's do an example on graphing an hyperbola whose center is not at 0, 0. Center is at some point hk. So this is the given equation. If the question doesn't say anything, if the question is just graph this, while analyzing this, you can see that two square terms, x square and y square, both are squared, and it's joined with the minus sign, so that might be a hyperbola. First step is add 388 and move to the other side. That means move the constant to the other side. Then group the term which has x and y, then factor out 9 from here, factor out 4 from here, so that the coefficient of the square term will be 1. Now we need to complete the square. So we need to add a constant here. That constant will be coefficient of x divided by 2 square. So negative 4 divided by 2 is negative 2. Negative 2 whole square is 4. Here we need to complete the square, adding the constant 25. We are getting 25 by dividing 10 by 2, 10 square. So 10 by 2 is 5, 5 square is 25. So we added two constant here. Basically we added 9 times 4 and negative 4 times 25. So we need to add the same constant on the other side so that the equation will balance. So 4 times 9, that is 36. So add 36 on the other side, and negative 4 times 25, that is negative 100. So add negative 100 on the other side. Then we are writing in the factored form. So this one in the factored form is x minus 2 whole square. This one in factored form is y plus 5 whole square. Now we need to make the right side equal 1. So divide each term by 324. So if you divide by 324, so this will cancel and you will get that is equal 1. And 324 divided by 4, that is 81, and 324 divided by 9, that is 36. So this is the equation of the hyperbola. So while looking at that, can you tell me the center? Where will be the center? Center is at hk, right? So we are comparing with the standard form x minus h whole square minus y minus k whole square. So h will be 2, k will be negative 5. So center is at 2, negative 5. And a will be 6 because square root of 36, that is 6. And b will be 9 because 9 square is 81. I just copied down the equation from the previous page. So here h is 2, k is negative 5. So center is at hk, 2, negative 5. And this is a square, this is b square. So a and b are 6 and 9. Since this equation is starting with x square minus, then the transverse axis is parallel to the x-axis. We can find c using the formula c square equal a square plus b square. C square is 36 plus 81, that is 117. 9 times 13 is 117. So c will be equal plus or minus square root of 9 is 3, and this will stay under the radical sign. So we can actually briefly start graphing this. Then while graphing we can decide whether we need to add or subtract, and based on that we can find the foci and the equation of the asymptotes. I am starting the problem with plotting the center first. So center is 2, negative 5. 1, 2, 3, 4, 5. So negative 5. I am briefly graphing. If you have graph paper, you can use the graph paper. So that is the center. This is the transverse axis. If you measure 6 units right and left from the center, you will get the vertices. And if you measure 5 units, is B 5? No. B is 9, right? B is 9. So you need to measure 9 units up or down to get the co-vertices. Vertices is on the axis parallel to the x-axis. So you will add 6 to the x coordinate. That means you will add 6 unit to the x coordinate of the center. But the conjugate axis, that is parallel to the y-axis, and the co-vertices is on this axis. That means you need to add 9 units to the y coordinate of the center. Foci is also on the transverse axis. So you will be adding c units, or adding or subtracting c units from the x coordinate of the center to get the foci. So if you add a unit to h, that is 2 plus or minus 6, you will get 8 comma k is not changing. So these two are the vertices. And if you add b units to k, so b is 9, so h is 2. So if you add or subtract 9 units, you will get negative 5 minus 9, that is negative 14, negative 5 plus 9, that is 4. So these two are the co-vertices. And foci, you need to add or subtract c Yeah, so h is 2 plus or minus c, comma k. These two are the foci. These are the equation of the asymptote when center is at 0, 0. If the center is not at 0, 0, we will replace this y and x by y minus k and x minus h. So replace this k, a, b and h by the values. Now reduce the fraction and subtract 5 from both sides to get the equation of the asymptotes. Now let's graph this. This is the x-axis, y-axis. This is 0, 0. We need to plot the center of the hyperbola. That center is at 2, negative 5. So starting from here, measure 2 units right, 5 units down. So 1, 2, 3, 4, 5. So that is the center. So write down the coordinate of that, 2, negative 5. Now mark the vertices, negative 4, negative 5 and 8, negative 5. Now mark the co-vertices, 2, negative 14 and 2, 4. Now make a box by joining these points. Now join the diagonal using dashed line, and you can extend that. That will be the asymptote of the hyperbola. So draw the diagonal like that. Okay, now mark the foci. We can approximately mark the foci. Foci are negative 8.8. So it will be somewhere here and 12.8. So it will be still on the transverse axis. That's why the y coordinate will be still negative 5. So foci is here. So now we can graph this. So draw a curve from the vertex. So draw a curve like that. And don't forget to write the equation of the asymptote next to the asymptote. This one is with the positive slope, this one is with the negative slope. These two pieces are the hyperbola. Now label the foci. Make sure you include all the information in the graph. The center, vertices, co-vertices, foci and the asymptotes. Let's do an application problem involving hyperbola. This is a cooling tower. The tower stands 179 meters tall. So the height is given and the diameter of the top, that is given. At their closest, the sides of the tower is 60 meters apart. So this is 60 meters apart. Find the equation of the hyperbola that models the side of the cooling tower. Assumes that the center of the hyperbola indicated by the intersection of the dash perpendicular lines in the figure. So this is the dash perpendicular lines in the figure is the origin of the coordinate plane, and round the answer to 4 decimal places. Let's see how to do the problem. They are saying this is the center 0, 0. So this length is given. So the hyperbola is this shape. So if this is the center, this distance is A, this distance is A. That means 2A is given. 2A is 60. If 2A is 60, that means A equal 30. This is the x-axis, this is the y-axis, this is the hyperbola curve. And this is a point xy that is on the hyperbola. If this length is 72, the x-coordinate of this will be 72 divided by 2, that is 36, and the height will be 79.6. So we can start with the equation of the hyperbola. X square over a square minus y square over b square equal 1. We know the value of x, y and a. This is a and this is x and y. Substitute all these for x, y and a and solve for b. We can actually solve this equation for b first, then substitute. First subtract 1 from both sides Then move this term to the other side. Then multiply both sides by b square. Then divide by this term. So that we will get b square by itself on one side of the equation. After that, substitute the values for x, y and a. Now substitute the values for x, y and a into the equation and use the calculator and solve. The question says round your final values to 4 decimal places, right? That's why we round it into 4 decimal places. And after that, we can write the equation of the hyperbola. Equation will be x square divided by a square. So a is 30, 30 square is 900, or if you want you can write like 30 square, that's also fine. Then this one also take the square root of that, then write in that number square form. In this section you learn how to graph the hyperbola whose center is not at origin, center is at some point hk, and how to solve applied problems involving hyperbola.